Hello again. Let me give you just a very brief review, I'm sure, for most of you, of interval notation. And this is related to the few homework problems that are in section 8.9 in the first assignment. Basically, interval notation is an efficient way of expressing a set of numbers that are all in a one lump on the number line. For instance, if you have a solution to maybe a compound inequality that says that all the values you're interested in are the x's, the real numbers, such that 2 is less than x and x is less than or equal to 5. So basically that's an inequality way of saying the number is stuck between 2 and 5, and it's got to be strictly greater than 2, but it could be equal to or less than 5. On a number line, of course, for the greatest economy, I just have to locate 2 and 5, of course with 2 to the left of 5 on a number line. And then the classic way of describing this set would be to describe this interval between 2 and 5 and use a closed dot to represent that 5 is actually part of this graphed set, and an open dot to represent 2 as an endpoint, but that 2 is not actually a member of these real numbers that satisfy that compound inequality. The open dot there suggests that 2.1 or 2.01 is part of the set, but not 2 itself. Actually, in this textbook, another style is used that's helpful for remembering interval notation. Instead of the open circle and closed dot, they'll generally graph using half a parenthesis for the open dot and half of a square bracket for the closed dot. So this would be the style that we'd see for number line graphs in our textbook. That's really suggestive of the interval notation. Recall that to describe this briefly in interval notation, you just put the endpoints of the interval down, separate them by comma, and make sure you've got the smaller number first and the larger number second. So this is always going to be the value that occurs to the left on the number line. And then use the open paren. If 2 is not included in the set, it's always going to be an open parentheses with less than or greater than. And use a closed bracket if you want to include 5 in the set. That's always going to be used if there's an equality possibility in there in the inequality, less than or equal to or greater than or equal to. You'll see the square bracket. So that notation is just a very compact way of saying all the numbers between 2 and 5, not including 2, but including 5. So a few more examples of applying that. -1 less than x less than 3. If I just locate -1 and 3 in their relative locations on a number line, and then I want to use open the parentheses rather than the brackets here to show that -1 and 3 are not included, and the interval notation would just have those endpoints in order with the parentheses around them. Now notice this kind of points out a weakness of interval notation. It's ambiguous when you see this whether this is an interval, as in this case, or an ordered pair that might name a point in the plane. Could be the point -1, 3 in the plane. But the context tells you what the meaning is. A couple others. Suppose you just want to describe the set x less than or equal to 5. Of course, that's unbounded in one direction. Everything from 5 and below. So a natural way to show that in a graph would be the square bracket. I hope that looks square. And just an arrow saying keep going that way. Everything that direction on the number line would be less than or equal to 5. So for interval notation, my top endpoint is 5, but there really isn't a lower endpoint. And so by convention, negative infinity, the infinity symbol just means keep going. No finite endpoint. Negative sign means that direction. I've got a square bracket on the 5 because 5 is included in the set, less than or equal to. And by convention, I'm always going to have a round parent on a infinity. So by convention, always parentheses there. One more quick example, x greater than -1. So locate -1, we're looking for all those values. The lower end point's -1, the top end point, no top end point, so use infinity and not including -1, and always round with plus or minus infinity by convention. Okay, so more than you ever really need to know about interval notation. See you later.